Okay, so the Chapter 5 review starts out with a first question, and I'm going to be going back and forth between the green paper so that I don't have to record all these graphs for you. So question number 1 says, the graph below shows a transformation of f of x equals the absolute value of x. Whenever you see these absolute value bars, that's your clue that you're going to know ahead of time that it's going to be this absolute value function. So it's this one that has that V shape. This one, the graph that you have right here, isn't centered in the middle of the graph. It's centered over here, or it's moved over here to the right. So that's the shift that we're trying to describe. Anytime you're moving an absolute value graph, remember you're always moving the vertex of the absolute value function, and then you're going to kind of figure it out from there. So for this one, it wants me to identify the new equation of the graph. So here's f of x. It didn't start in the middle, it moved over to the right. This is from 0 to 2, and then it's halfway between 2 and 4, so that's how you know that it moved 3 to the right. When you write your equation for number 1, it says f of x is equal to, and then you have to write the numbers that work for this graph. So f of x is equal to, it's going to have absolute value bars because that's the shape of the graph, and then it moved 3 to the right. Right and left shifts happen inside the absolute value bars, and we said that inside is opposite. So that's why it's going to be x minus 3 on the inside of the bars. A lot of people would put plus 3 right here, but make a note that you want to remember that inside, it's always the opposite of the sign that you see on the picture for the graph. So inside is opposite, and that'll hold true with horizontal and stretches and compressions as well, and we'll get to those in a little bit. Question number 2, it shows, the graph below shows a transformation of f of x is equal to x squared, and so the squared exponent is what gives this graph its parabola shape. It says to identify the equation of the graph. You're going to do the same thing with a parabola as you did with an absolute value graph. You're trying to see where the vertex moved. So this parabola is still centered on the y-axis, but it got moved down too. The up-down shifts are your k-shifts when you write your function. So for problem number 2, it says f of x is equal to, this one isn't going to have absolute value bars because it's a parabola, but it's also not going to have the number on the inside. It's going to have the number on the outside. Your h shift is what makes the graph move left and right, but it's your k shift that makes the graph move up and down. So this one is going to say x squared, and I don't need parentheses around the x squared because there is nothing moving in here. And then x squared, and then it's going down 2, so minus 2. And so because this is on the outside, it's only inside that's opposite. So x squared minus 2, this is what moved the graph down 2. You might want to, as you're doing your review, just make a note that this graph moved 3 to the right, and that this graph moved down 2, because you might be asked to look at just the equation here and describe how things moved, not given the graph. And so this would mean 3 to the right because negative 3 moves it 3 to the right. And this would mean down 2 because a negative 2 on the outside moves it down 2. The third graph on this page is another absolute value graph. So I know it's going to have bars like the first one did. It's not going to have the squared like the second one did. But there's a couple of different things that have happened to this graph. So you want to be careful in describing how it moved. So it moved 2 to the right. It moved up 3. And it was flipped upside down. So there was a reflection across the x-axis. And so when I write my equation for this one, I need to make sure that the numbers that I put down indicate all of those moves. So f of x is equal to, I know that this one's going to have bars because it's an absolute value graph shape, and so my work will have bars on the answer. F of x is equal to the absolute value of x. It's moving 2 to the left, so x plus 2 would move it 2 to the left. It's moving up 3, so plus 3 would move it up 3. And then there's just one additional thing that I need to add onto my work. This graph would still be opening upwards, but this graph is opening downwards. So when you write your answer to this question, you want to make sure that you leave yourself enough space to go back and add in the negative at the beginning, like I didn't do. So it's going to be negative the absolute value of x plus 2 and then plus 3. So the negative is a reflection in the x-axis here. Let's list these ones out as well. So this graph would be a reflection across the x-axis, so it flips it upside down. It's also moved 2 to the left. The plus 2 on the inside moves it left 2. and then the plus 3 on the outside moves it up 3. So the left 2 up 3 are how the vertex moves, and then the reflection is whether the graph's opening upward or whether the graph's opening downward. The last graph on this section is the parabola again, so I'm switching back and I'm going to have there be a squared. On this one, the vertex of the parabola has been shifted upwards, and so it's up at, if this is 2, this is 1, so it's being shifted up 1. But then there's something else that's happening to the parabola of the graph. If you go back to this first original one up here, you want to always check the scale to make sure that it's going over 1, up 1, because you're trying to make sure that there's no transformations horizontally or vertically when you're doing these ones as well. So when you do number 4, you notice that the vertex moves up 2, you notice that it's flipped upside down. You also want to make sure that from here to here is over 1, down 1. And it kind of looks like it's not, but remember you're counting by halves, because this is 2, so this is 1. So this is over 1, down 1, and this is over 1, down 1. So there's no kind of vertical or horizontal stretch or compression that has happened with this graph. When I write my answer for number 4, f of x is equal to, it's a parabola, so I'm going to have a squared. It's flipped upside down, so it's going to have a negative. And then last but not least, it's moved up 2. So negative x squared, that flips it upside down, and then the plus 2 on the outside moves it up 2. So this would be a reflection across or in the x-axis, and then the plus 2 is what moves it up 2. And because the plus 2 is on the outside, it doesn't need to be the opposite. If it were moving left or right 2, I would have to put that inside the parentheses here with the x. So that gets us through the first 4, where we're looking at, well, there's a couple things you could study from here. So you're given a picture of a graph, and you can write an equation. But you can also study, if you're given an equation, if you write down the words, you can study how the graph's going to move, and that would be helpful for you in identifying other types of transformations that could potentially happen with regard to the graph. You also want to make sure that for the 2 that were absolute values, those ones had the bars on the answer, and then for the 2 that were parabolas, those ones have squares on the answer. Question number 5 gives us an original function. So it says f of x was x to the second, and then it gives us a new function, and it wants us to describe how it changed. So it says f of x is equal to x squared. So they define f of x to be x squared already. So we know it's a parabola that we're working with. And then it says g of x is equal to, so the new function is the old one. F just means the old function that they told us already. And then there's an x minus 5 on the inside of the parentheses, and then there's a plus 9 on the outside. So there's a couple different things happening on this graph as well. The minus 5 on the inside is going to do something, and remember, inside's opposite, so it's going to be the opposite of whatever it does. And then the plus 9 on the outside. And so it's a fill-in-the-blank type question where you're circling the words to describe how it's moving. So it says it's moving 5 units, and so this 5 is either going to move it up, down, left, or right, and then the 9 is either going to move it up, down, left, or right. So it's going to be a transformation of the graph 5 units. Notice that the 5 is on the inside, so inside is opposite. Inside is also an H shift that moves this graph either left or right. And so this is going to be 5 units to the right because it's opposite. Right usually means positive, but because it's negative, it moves it 5 units to the right. And then the plus 9 that's over here moves the graph 9 units, and it's plus 9. It's on the outside, and so outside's not opposite. Outside's the same. And so this one moves it 9 units up. So the correct things to circle for your answer for number 5 would be that it moves it 5 units to the right and it moves it 9 units up. Question 6 is worded similarly. On question number 6, it says describe how to transform the graph of f of x equals the absolute value of x to obtain the graph of the related function g of x, and so then it tells you here's g of x. So g of x is the original function f, and then there's a 1/4 on the inside, and then there's a plus 6 on the outside. And so it wants us to describe how these are changing. Notice that when the original one is defined with a squared, you don't have to have a squared right here because you already said that f means it's this function you're talking about. Same goes with this one. The original function was an absolute value function, so the new function doesn't have bars on it, but it's still a v-shaped graph. It's just you define it by f, so it's saying that this function matches with this one here. So we're talking about how it's changing. So the first one says it's either a horizontal or vertical stretch or compression. And so this is sometimes where students get a little bit confused. This is the harder part of the lesson. So you have to notice where the number is. This number 1/4 isn't out in front of the f. It's not happening after the function is evaluated. It's happening before, so it's happening to the x's before it's acted on. The 1/4 that's on the inside, because it's on the inside, it means it's horizontal, and so that would be the first word that you would be selecting. So this is going to be some kind of horizontal change. When it's vertical and on the outside, a whole number means it's a stretch, and a fraction means it's a compression. When it's on the inside, remember that inside is opposite. Let's make that note again. And so this 1/4 that's on the inside is really a number 4, and it's not a compression, it's a stretch. So it's a horizontal stretch of f of x by a factor. I can squeeze that up there. So it's a horizontal stretch by a factor of 4. And so the 4 is how it's stretching horizontally, so it's pulling it from side to side. And then the second thing that happened in this graph, it says that it's a translation of 6 units, and then you have to decide whether the 6 moves it up, down, left, or right. Notice that the +6 isn't inside the parentheses, the +6 is outside the parentheses. So this is a k-shift, and so that means that the translation that's going to happen there is that the graph's going to move 6 units, and then the +6 is going to move it up 6 units. So that's how that graph would be changing. Question number 7 starts the new section. So that was all 5.1. This is where 5.2 starts. So question number 7 says, the following shows the ordered pairs for a 1-to-1 function, and it shows the numbers in the list. So the numbers that it shows you for the original ones, here I'll write down the ordered pairs. So it's 20, 41, so that's the first ordered pair. 13, 15, 37 goes with 52, 52 also goes with 15, and then last but not least in the list, so 11 goes with 45. So that's your original set of ordered pairs. And then the directions to the question for number 7 say, which of the following shows the correct ordered pairs for the inverse of the function, for the 1-to-1 function? So you want to remember that anytime you see the word inverse, what you want to remember is that no matter whether it's a function, a graph, a table, anything like that, the rule says that the x's and y's switch. So they trade places. This is like the key thing to remember about inverses. So as you're looking down the list, you want to make sure that not just the 40 and the 41 and the 20 switch places, you want to make sure that they all switch places. So this is a multiple choice question. So the 40 and the 21 switch places on B and on C, and then the 15 and the 13 switched places, the 37 and, oh, so that's the problem then right here. The 37 and the 52 also have to switch places, so they only switch places on B, they don't switch places on C. So the correct answer for this question would be B, and so to identify that B is the answer to the question, you want to write down the list of the ordered pairs. So this one switched, so 41 goes with 20. The next one switched, so 15 goes with 13. The next one switched, so 52 went with 37. And then the other one was also backwards too, so 15 goes with 52. And then 45 goes with 11. So it's hard. You might get fooled when you're doing this question because these ones were the right way, these ones were the right way, and these ones were the right way. So it was only these two, like the third and the fourth ordered pairs, that were given to you in the opposite order. And so you're being mindful of that. Question number 8, part of it needs to be graphed, but we'll do number 8 right here, and then we'll just grab graph paper to do the other part for question 8. Question 8 says to consider the function, and it gives you a set of 4 ordered pairs. So -4 goes with -4 goes with -1. That's the first ordered pair that's in the list. And then -2 goes with +2. +1 goes with +3. And then last but not least, 4 goes with +1. So those are the numbers that are in the list. The first part of number 8 says to write the inverse of the function. And so just remember up above, if it's an inverse, it says the x's and the y's are going to switch places. So the inverse of this function would be -1 goes with -4. I'm literally just switching where the x's and the y's are located. +2 goes with -2. +3 goes with +1. And then +1 goes with +4. And so that would give me the ordered pairs listed out as the inverse of the function is written. You just want to look at them and make sure that you remember to switch the x's and the y's in all of them. So that's part A of that question. So this one right here would be the inverse. And then the next part of the question says that they want you to graph the original function and graph the inverse of the function on the same axes. So all my numbers are pretty small. So when I do the graphing question, I'll come over here to a piece of graph paper. So this is 8b. So I don't have that large of numbers, so I should be okay drawing a relatively small graph. So I'm going to graph the original points, and then I'm going to graph the new points on this function, and I'm going to go ahead and do that in different colors so that you can see them. So we'll graph the original one in black. So the original function was -4, -1, and then -2, +2, +1, +3, and then last but not least 4, +1. And so the points in black are the points for the function. Once you have those graphed, so I have the 4 points graphed for my regular function, then I'll go through and I'll graph I'll do it in a different color for you. So these are the points for the inverse. So you're not moving these points. You're going to see the shape it makes, but you're not actually moving those points. You're just going to look at your list from your other piece of paper. So when I flip-flop them, now -1 goes with -4. Let's be careful to count them right. -2 goes with +2. So +2 goes with -2. +3 will go with +1, and then +1 will go with +4. So what happens, and you might remember this from class, is that they don't form a straight line with each other necessarily. But if you were to graph the line y equals x, so if you were to fold this quadrant in half, and if you were to fold this quadrant in half, all of the points are equal distances from that fold line. So this one's the same distance away as this one. This one's the same distance of the line as away from this one. These two buddy up and they're the same distance away, and then these two buddy up and they're the same distance away. And so that's how you can tell that a graph is the function, or that a graph is the graph of the inverse of a function. So questions 9, 10, and 11 ask you to find the inverse to each function algebraically. And so you're given an original function, and then you're asked to go through and you're asked to find the inverse. So in finding the inverse, you have to take the original function, and then there's a couple of things that you're going to do. So we'll go through and we'll follow those steps together. So here's my original function, f of x equals 3x minus 1. The first thing is, remember that the rule for inverse is say you switch the x and the y's. We wrote that down on the other page. But right now you see that there's x's here. It kind of also looks like there's x's here, and then it doesn't look like there's any y's. So start by writing the function down. And then your first step is to be, you're not actually getting rid of it, but you're going to say that you recognize that f of x and y are in fact the same thing. So your first step is to change the f of x into a y. So it's going to say y equals 3x minus 1. Okay. Once you change the f of x out for y, now you have an x and a y. And so you're not going to do any math right now. You're going to pick up the x and put it where the y is, and then pick up the y and put it where the x is. So in this step, this is where you switch the x and the y. So this is that step that you want to remember. You switch x and y where they are in the problem. And then to finish finding the inverse to this function, now this is where you start doing algebra, where you do the steps on both sides. You're going to resolve the equation to get the y all by itself. So I'll add the 1 to both sides. Remember, when you add the 1 over here on the left, x and 1 are not like terms. These ones over here, one's positive, one's negative, so those cross out with each other, so those are gone. But this side, it doesn't turn into 1x, it turns into x plus 1 is equal to 3y. And then to get the final answer for this inverse, I'll divide both sides by 3. So getting the y all by itself here, I'd have x plus 1 over 3. So the y is all by itself, but there's a couple different things about how this answer could be written. One thing is that because you started with f of x, when I write the inverse, I'm going to write it like this, with this notation that indicates that that's an inverse. So I could write the answer to the question like this, or sometimes you'll see it broken up so that it's two separate side-by-side fractions. So x could go over the 3, and then 1 could go over the 3, so that would turn into 1/3 x plus 1/3. It doesn't matter which way you write it, but you do want to make sure that when you're the one writing them down, you know that they're the same. That way, if you ever encountered something like this in a multiple choice scenario, you would know how to do the question to get the answer to the question right. So question number 10 and question number 11, this would be a good place to pause the video if you felt like you could try a couple of these on their own. You want to make sure that you're not following the videos too closely to help you get your answers to these questions. Because, well, if you do, it's fine. You just want to make sure that you do the review a second time again, because you ultimately have to get to the point where you're doing these by yourself. So this one also says find the inverse. And so the first thing I do is I write down the function. So x plus 7 over 2. This one also starts with f of x. So I'm going to remind myself that f of x is the same thing as y. So I'll rewrite it with a y. So y equals x plus 7 divided by 2. And then to find the inverse, remember I haven't changed anything yet. I just rewrote it with the y right there. Now I'm going to switch the x and the y. So I'm going to switch where they are. Up here in this problem, I wrote it on this line, but it was kind of like that's what happened here. And so the same thing for this one. I'm going to change where the x and the y are located. So it's going to be x equals y plus 7 over 2. And now I'll do algebra to get the y all by itself again. So I'll times both sides by 2. So this 2 will cross out with this 2. So that'll give me 2x equals y plus 7. And then I'm trying to get the y all by itself. So I'll finish by subtracting the 7 from both sides. Remember, right here, 2x take away 7 doesn't turn into negative 5x or anything like that, because they're not like terms, so they can't combine. So you get the y all by itself. The original function was written as f of x, and so when I write my answer to this question, it'll be written in inverse notation, so with the negative 1 right here, so you know that's what you're trying to find. And so that'll be the answer for that inverse. And then question 11, the steps are much the same as question number 10. So find the inverse, and I'm given the function f of x is equal to 3x plus 5 over 9. So I'm going to do the same steps to follow this one. You can drop the f of x right here if you want to before you rewrite it. So I know this will be a y, and then I'm going to skip the step of rewriting it before I switch them. So now that I have this as a y, I'll switch my x and my y. So it'll be x equals 3y plus 5 divided by 9. And then I'm going to go through my solving steps to finish getting the y all by itself again. So I'll times both sides by 9. Let's see, that'll give me 9x equals, these cross out, so 3y plus 5. And then I've just got my 2 steps left over to get my y all by itself. I'll minus the 5 from both sides. So that'll give me 9x minus 5 is equal to 3y. And then to finish getting the y all by itself, I'll just divide both sides by 3. And so that would get the y all by itself right there. Again, this one started with f of x, so when I write my notation for my answer, I'll use inverse notation with the function. And so I could write it as 9x minus 5 divided by 3, or if I split this up into 2 fractions, 9 divided by 3 would give me 3x, and then 5 divided by 3 would just stay 5/3. So these two answers are actually exactly the same. There's nothing different about them. When you're doing the work for them, though, just make sure that if you saw one written one way and one written another way, you would feel confident with the fact that those are the same thing. So again, the 3 gets split up, and it gets put under this one, and it gets put under this one, and then each of them gets simplified separately. So that's where the 3 on the x comes from, because 9 divided by 3 gives you 3. So we've got one more question to find the inverse of. This one says find the inverse. And the function that's given to us is f of x is equal to negative 1/3 x minus 2. And so, again, the process with this one's the same. I'll change my f of x to a y so I have something to switch with. And then I switch the x and the y with where they're located. I don't switch anything besides the x or the y. So the negative stays here, the 1/3 stays here. I just flip-flop them where they're located. And then there's a couple different ways that I can do the work to answer this question. A lot of students like to move the 2 over first. You could handle the negative and the 1/3 now, or you could handle it later. Either way, it's fine. These would cross out. So you're going to have x plus 2 is equal to negative 1/3 y. And then remember, you're trying to get the y all by itself. So when you finish this question out, timesing both sides by 3 would just get rid of the 3 that's in the denominator of the fraction. But so if you times both sides by negative 3, That's going to multiply, so the 3 will cross out with the 3, and the negative will cross out with the negative, so that will get you the y all by itself. Just be careful on this side, because that negative 3 is being multiplied by the whole thing. You could write that the function for this one is negative 3 times x plus 2, so it could be written in that format. Or if you did the distributive property, it would be negative 3x minus 6. And so again, both of these would be accepted as correct. And you just want to make sure that you know that they're the same thing in case you encountered them in a multiple choice type setting. Question number 13 goes back to transformations of graphs. But on 13, I'm not transforming the type of graphs I was transforming on the other side. So these are not absolute value graphs and x squared graphs specifically. The graphs on this page, starting with question 13, it says we're going to describe how they're related. But notice that on question number 13, they all have x to the thirds on them. So these are these S-shaped graphs that have different end behavior. But the transformations are luckily the same. So it says describe how the graph of g of x is related to the graph of f of x equals x to the third. And so this is 4 problems, so A, B, C, and D, where you're going to answer all of them. It's not multiple choice question. So A says g of x is equal to x minus 2 raised up to the third power. So the third powers match, so you know they're going to be the same shape. So on this one, all you want to notice is that the minus 2 is an H shift. It's on the inside, and remember that inside is opposite. So this graph, the answer for this question would be that it moves the graph 2 units to the right. So this one goes right 2 units. The negative on the 2 moves it to the right because it's the opposite of what you think. The next one is negative 1/4 x to the third, written in this manner. So there's a couple things happening here. The 3 doesn't change anything because that's just the shape of the original graph. That's all the 3 means. But this one has a negative out front, and it has a 1/4, and the 1/4 is on the outside. So there's 2 things happening with this one. There's a reflection in or across the x-axis, so it's going to flip the shape or the direction of the graph. And then the other thing that's happening is you have a 1/4 on the outside. So if it's an outside 1/4, it means it's acting on the graph after it's already been graphed. So this is going to be a vertical transformation, and so this is a vertical. It's on the outside, so a fraction makes things smaller, so it's a vertical compression by a factor of 1/4, and so it's compressing it by a factor of 1/4. So when it's on the outside for vertical, it's just whatever the number is. A whole number makes it get bigger, so it's a stretch. A fraction makes it get smaller, so it's a compression. When it's on the inside, and if it's a horizontal change, then it's always the opposite, because inside is opposite. And that's the next one. So for the next one, g of x, the function that's given is, there's only one thing happening on this one. Notice that on this one, the 1/4 wasn't inside parentheses with the x, but notice that on C, the 1/2 is on the inside with parentheses with the x. So for this one, I'm going to describe what's happening. The 1/2's on the inside, so it's horizontal. Horizontal transformations are always on the inside. And then it's a fraction, so normally fractions mean compressions, but when it's a fraction on the inside, it's the opposite, because inside is opposite. So this is going to be a horizontal stretch. And then I wrote by 1/4 on this one. Technically, it should be by a factor of 1/4. And so for this one, it's by a factor of 2. Notice that it's not a 1/2. So this one, the 1/4 stayed 1/4, but on this one, the 1/2 turned into a 2. So when it's horizontal, it always flips to give you the answer to the question. And then last but not least, here's the final one. So g of x is equal to, this one's also going to be horizontal because the 5 is on the inside. Usually whole numbers make things bigger, but inside is opposite. So this one's going to be a horizontal compression. And it's by a factor of, but I'll just write by, but it's 1/5. So whatever the number is here, it changes. So it only changes when it's horizontal. When it's vertical, it stays the same as whatever the number was where it started. All right, question number 14 gives us a graph. And the graph is pictured here on the worksheet that you were given. And so it's negative x to the third, and it wants us to identify the following based off of the graph. So there's a couple different things we're going to keep in mind when we do the work for this question. Let's see, f of x equals negative x to the third. So I'm being asked to state the domain. I'm being asked to state the range. And then the end behavior. So as x approaches positive infinity, f of x approaches, and then I'll fill that in. And then as x approaches negative infinity, f of x approaches, and then I'll fill that in. So those are the last two things that I'm going to find. So for this one, for negative x to the third, your domain is your x values and your range is your y values. That's always the same thing. So when you find your x values, most people put their hand in the center of the graph or their pencil, and they move it left to right. You can put whatever you want. You can put in whatever you want to the left for this graph, and you can put in whatever you want for the right for this graph. So there's no restriction on the domain that you can put in. And so that's why when I write my domain for this problem for number 14, my domain is all real numbers. So it's from negative infinity to positive infinity. Everything works for my domain. When I do my range, I do the same thing. So I move my pencil this way for my range. So it can be anything up here has a range value, and anything down here has a range value. It's different than a graph like the next one, where it only goes one way. And so for this one, my range will also be negative infinity to positive infinity. So that just means that it goes everywhere. For the last part, as x approaches positive infinity, so as x is going to the right, remember the little shortcut you can use when you're doing this. And I know I'm writing on the green paper and I'm not supposed to. As x approaches positive infinity, so as x goes bigger and bigger and bigger and bigger, you look at where the end of the graph is pointing at, and so that means y is approaching negative infinity. So as x gets bigger and bigger, the graph's pointing down here. So as x approaches positive infinity, y approaches negative infinity, and then the same thing works for the other side of the graph as well. As x approaches negative infinity, so as x gets smaller and smaller, you can see the end of the graph is pointing towards positive infinity because the graph keeps getting bigger and bigger. So as x approaches positive and negative infinity, y approaches positive infinity. For question 15, it's a different graph that we're looking at. So this is f of x is equal to positive x to the fourth power. And so I'm doing the same thing as I'm going through here for this one. This is x to the fourth, so I'm still going to answer the same 4 questions, but let's talk about them before we write the answers down. I can still put in whatever I want to for my domain because this graph goes to the right and it goes to the left. But look at the range. This graph only exists up here in the top part of the graph. It doesn't exist down here on the bottom. So when I write my range, I'm going to have to write it a little bit differently. For this question, my domain is still negative infinity to positive infinity, but my range is different. So for this one, the range is the lowest number it goes is 0, and then it goes up forever and always. This square bracket on the 0 means that it starts at 0. If it started at a different number, like if it started at the number 1, you would just put a 1 here. But this is a little bit rare to see. You might want to make a note. That means it starts at 0. And again, if it started at a different number, then you would just put the different number right there. So it starts at 0, and it goes up from 0. The last question for number 15 wants us to do the end behavior. So as x approaches positive infinity, f of x approaches, and then we'll answer that. And then as x approaches negative infinity, f of x approaches, and then we'll answer that. Remember that you can use that little shortcut when you're doing this one too, though. So the positive infinity goes at the top, 0 in the bottom, negative infinity at the bottom, positive infinity at the top, 0 in the middle, and negative infinity at the bottom. So as x gets bigger and bigger and bigger and bigger, the graph keeps going up, so positive infinity. And then as x keeps getting smaller, so as x goes to the left, to the left, to the left, the y is also getting bigger. So you're looking at where the graph is pointing and kind of which direction it's going at. So f of x would be approaching also for this one, positive infinity. So on this graph, both the left and the right side of the graph are both going up, whereas on this one side of the graph was going down and one side of the graph was going up. And so when you do end behavior, you're trying to describe how the end of the graph is changing. Question number 16 gives us a picture of a graph. It says to write a cubic function in intercept form for the given graph whose x-intercepts are integers, and they want you to assume that the constant factor a is either -1 or +1. So this last thing means you just don't have to worry about any kind of a stretch. So when you're doing the work for this one, you're looking at the picture of the graph, and you're trying to describe what's happening. The graph turns twice. One end is going up and one end is going down. And so that's how I know that this is going to be x to the third. It also told me that it was a cubic function, and cubed means x to the third. So this graph because it's going down to the right and up to the left, it means that it's been flipped. So I know I'm going to have some kind of a negative out front. I can also tell that I have an x and y intercept here at 0. That means I'm going to have a regular x somewhere in the question. And then I also have an x-intercept over here at positive 3. So I'll need to remember how to do that with intercepts. The value here, 2, doesn't come into play in terms of answering your question, so you don't have to worry about that part at all. So when I write my function for number 16, f of x is equal to, I need to keep all those things in mind when I'm writing it. It's to the third power, so I know I'm going to need it to the third power. I'm going to need 3 x's total when I'm done writing it. It's flipped because it's backwards x to the third. Regular x to the third would come down and it would be facing this direction, so it would be going the other way through it. But this has been reflected. The reflection in the x-axis can be one thing that we note about it. That's what's going to give us the negative out front. And then, although this graph crosses the x-axis twice, it crosses here and here, it's to the third power, so I need to have 3 x's on my answers. So a couple different ways you can remember. This point right here is tangent to the x-axis. Sometimes we call it a bump, like it's coming up and, well, it's coming down, but it's fist bumping right here at 0. So that means that there's going to be a double 0, or there's going to be 2 x's that intercept there at 0. And then remember, inside is opposite, so my other x-intercept is going to be at positive 3. And so when I write it in function form, I write it as x minus 3. This means that the graph comes up to 0 and bumps at 0, but doesn't cross at 0. That's where those 2 x's come from. And then the third x, or the third 0, comes from where it crosses at positive 3. So this would be the function rule for that. In terms of writing down what's happening with this function, because that's helpful too, you can say there's a reflection, so it's backwards. And then you can say that this graph has 2 x-intercepts. And so the 2 x-intercepts that this graph has are at x equals 0 and at x equals positive 3. And so that describes the way that the graph is set up and located. In question number 17, there's a couple things about it that are different, but notice that it's the same shape. So it's still that S shape. It goes up to the right and down to the left, and that's how I know that this one hasn't been flipped. So it's not backwards, so it's not going to start with a negative the way this one did. It bumps at -1. It crosses the y-axis at -2. That's just good to notice. And then it crosses the x-axis over here at positive 2. So there's only 2 places that it crosses, but it's x to the third power, so you're going to have 3 x's. So that's why this one's going to get a squared on it. This point is tangent to the x-axis here. It comes up to it and touches it, but it only touches it once. It doesn't touch it twice, and so that's where it's going to need the squared. Because it has this S shape to it, that's also part of the reason that I know that it's going to have 3 x's. So for this one, it crosses at -1, so that's going to be x plus 1, but it doesn't cross there. It actually just hits there, and then it turns around and goes back where it came from. So that's why it needs the squared, is to show that there's 2 things happening there, but that's where my 2 x's come from. And then the other place that it crosses is at positive 2, and so that'll be x minus 2 when I write it out in this format. So this one has 2 x-intercepts. And they're at the points x equals -1 and x equals positive 2. So wherever the x-intercepts are, remember that this is backwards from that. All right, question number 18, 19, and 20. It asks us questions about it, but then it also asks us to create sketches of it. So for these last couple of questions, I'm going to go ahead and just switch and do them on graph paper. So for question number 18, the problem says, consider f of x is equal to, so there's x plus 1, this is a polynomial function, and then x minus 1, and then the last one is x plus 3. So you count up how many x's there are. So there's 1, 2, 3 x's. So you know this is going to be an x to the third function when you come over here to graph it. The first thing it wants, though, is the end behavior. So as x approaches positive infinity, f of x approaches, and so we'll answer that. And then as x approaches negative infinity, f of x approaches, and then we'll answer that. You could answer these depending on how much you know about the question. Sometimes knowing the end behavior helps you do the graph. Other times, it's easier to start doing the graph and then kind of come back and sort of do them at the same point. And so that's what I'm going to do for this one. So I'm going to create a sketch of the polynomial function. By making a sketch of this polynomial function, I'm also going to be able to identify the x-intercepts and the y-intercepts. So even though those aren't asked for, I'll make a note of what they are because it's going to help me draw my graph accurately. So two things, the x-intercepts are always the opposite of these numbers. So this graph is going to cross at -1, this graph is going to cross at +1, and this graph is going to cross at -3. So these three places are the three places on the graph where it's going to cross. So it'll have a 0 at -1, it'll have a 0 at +1, and then it'll have a 0 at -3. It doesn't matter what order these are written in. So it's either going to cross these from left to right or from right to left. Well, I guess it's the same thing either way. But so it's going through these 3 points. It's not doing it in the order that they're listed. It's just doing it sequentially. The y-intercept, you multiply this number, so +3 times -1 is -3, times +1 stays -3. So my y-intercept for this graph is going to be down here at -3, and so that kind of helps me figure out what I'm aiming for. There's no squareds on this one, so there's not going to be any points that are tangent to the x-axis. There's not going to be any bumps or any turnaround points here. So it's x to the third, so it's going to look like the letter S. But if I started from up here, if I did it backwards, which is wrong by the way, it would come through here, it would turn around somewhere, it would come through here, and then the x-intercept, rather the y-intercept, would have to be somewhere up here. And so that's how I know that that's wrong. I also remember that this function being odd means that unless it's reflected, it goes up to the right and it goes down to the left. So it's going to be the opposite of what I was just drawing. It's going to come up through here somewhere. It's going to turn around. Don't worry about the exact value of this point right here because it's just a sketch. It's going to come down here. It's going to go through the y-axis at this point, and then it's going to continue coming up in this direction. I usually do it lightly to make sure I'm drawing it in the right way. You guys, if you get stuck, so if you're going through and drawing this and you feel like you're not turning it around in the right spot, or if it feels like there's not somewhere to turn around, it might mean that you miscounted how many x's there were going to be in the problem, but it might also mean that when you were doing the question, you started it going the wrong way. So again, if I started it from up here, I would go down and up, but then I couldn't get down here to cross the y-axis. So that's why labeling these points ahead of time can sometimes help you. Remember, for the end behavior, this is positive infinity, this is 0, this is negative infinity, and then this side of the graph goes the same way. So as x approaches positive infinity, as x goes to the right, y approaches positive infinity as well. As x approaches negative infinity, so as x goes to the left, f of x is approaching negative infinity. So the graph is going down. So those would be the answers for those questions. 19 and 20 are very much the same in the sense of the process that you go through. For number 19, it says f of x is equal to, and so this one has a negative out front, so that'll change a couple of things. I have an x minus 1, I have an x plus 2, and I have an x plus 3. So when I count up my x's on this one, I still have 1, 2, 3 x's. And so 3 x's means it's going to have the same general shape as this graph. It just might look a little bit different depending on the information that's presented to me. So as x approaches positive infinity, we'll say where the graph is going. As x approaches negative infinity, we'll say where the graph is going. And then to help us graph it, we'll also list off our x-intercepts and we'll also list off our y-intercepts. And we can actually do this part now. So doing the x-intercepts and y-intercepts on this question are going to help me when it comes to graphing it. It's going to help me make sure that it's in the right spot. You want to make sure that you practice doing the graphing part on this, even though on your answer key it doesn't have the graphs listed, because you'll need to know how to graph something like this freehand. So on the test, well, or in life, but you're going to need to know how to draw the picture of this graph without having access to a graphing calculator. If this question was on the graphing calculator part of the test, then you'd be fine to answer it. But just remember, you're going to need to know how to do this without that y equals function. So this graph has 3 x-intercepts. So it crosses at +1, it crosses at -2, and it crosses at -3. So it crosses at these 3 places. But you want to be careful with the y-intercept, because when you're done multiplying these together, you also have to multiply it by this -1 that's out front as well. So 3 times 2 is 6, 6 times -1 is -6, but then the negative out front switches it back to be +6. So this graph is going to cross the y-axis at +6, not at -6. So +1, -2, and -3, those are the 3 places that it's going to cross the x-axis, and then 1, 2, 3, 4, 5, 6. It's also going to cross up here. So you can start with the end behavior or you can end with the end behavior. This negative out front means it's going to be this graph, but it's not going to be going up to the right and down to the left. It's going to be doing the opposite of that. So it's going to be coming from the top over here and coming down over here to the bottom. So it's doing the opposite. Let's say you didn't remember that though. You'd go up, you'd have to come back down, but then in order to get over here, you'd have to be crossing your y-axis somewhere down here instead of somewhere up here where you're supposed to. And so when you're doing the work for this question, it's the opposite way. So it's going backwards. It's not coming up, down, up. It's going to be coming from this direction, and it's going to be going down here, and then it's going to be coming back up and turning around and then coming back through this point, and then it's going to be finishing in this general direction, and so it's going to be finishing down this way. So the end behavior is going to be the opposite of the last graph. It doesn't matter exactly where your turnaround points are because that's not what we're testing. We're just testing that you have your intercepts right and also the shape of the function in general. So for this graph, positive infinity, 0, negative infinity, and then positive infinity, 0, and negative infinity. So for this graph, as x gets bigger and bigger, y is going towards, or f of x is going towards negative infinity. And then as x gets smaller and smaller, the graph's going up, so it's going towards positive infinity. So these two graphs are really similar, but this one was the flip-flop of this one. This one was flipped this way to turn into this one, and then there were some other things about it that were slightly different. So last but not least, the final function that you're graphing is going to have a different shape than these two that you've graphed already. So for number 20, last one, the function is f of x is equal to, and then there's an x minus 2, there's an x plus 2, and there's an x minus 1, plus 1. So we'll answer the question about the end behavior for both sides of the graph. It's usually written like this, so it does to the right first and to the left second. But just remember, positive infinity means to the right and negative infinity means to the left. So these could be flip-flopped and you might have to answer the left first. So just be careful about that. This graph is different than the first two graphs that we've done because this graph has 4 x's. There's the one here, and the one here, so that kind of looks the same as up above, but then there's this 4th x out front. So this is going to be a W-shaped graph. It's not going to have this S shape to it. It's going to have one extra turn, potentially, and then it's going to be going back up in the other direction. So the left and right behavior of the graph will be the same. Both of these numbers, whether they're positive infinity or negative infinity, will be the same. My x-intercepts for this graph are, it has a positive 2, a negative 2, and a negative 1, but it also has this x out front, which is x plus 0. And so if you want to write in the plus 0, it's not going to ever be written for you, but it's good to remember that that would be the number that would be next to it. So this graph has 4 x-intercepts. It crosses at 0, positive 2, negative 2, and negative 1. And then when I find my y-intercept, I just multiply those numbers together. So 1 times 2 is 2, 2 times negative 2 is negative 4, but negative 4 times 0 gives me 0. So the y-intercept for this graph will also be at 0. And so when I draw the graph for this function, it's going to look, it's going to have aspects to it that are the same as the ones that we've done, but it's not going to be exactly the same. This graph crosses at 0, it crosses at positive 2, it crosses at negative 2, and it's going to cross here at negative 1. So those are the 4 places on the graph where it's crossing the different axes. The y-intercept is also 0, so it's not going to cross up here, and it's not going to cross down here. It has to go through the middle. And so when you're doing your work for these points, you kind of have to think about what's happening. So if I came up here and turned around and came down through here and turned around and then came up through here and turned around and came down through here, that could work. But x to the 4th graphs, if they don't have a negative out front, they have end behavior that's positive, so it's going up on both sides. So to graph this one the right way, since the y-intercept was at 0, you don't have the y-intercept to help you decide whether it's an up graph or whether it's a down graph. So you just have to rely on what you know. Anytime you have 4 x's, it's always going to be a regular W unless there's a negative out front, and then it would flip it to be sort of an M-shaped graph instead. So it's going to start from coming up in this direction. It's going to cross here. It's going to turn around and cross here. At some point, it's going to come up and then turn around and cross here. And remember, don't worry exactly about where these points are because that's not what we're testing. Technically, this point, though, is further away, so it's probably going to come down lower here before it comes and turns and goes back up, and then it finishes going up in that direction. So it had an extra turn and an extra X-intercept because there were 4 x's instead of just being 3 x's. And so here we go. My end behavior for this one, as x approaches positive infinity, the function's going towards positive infinity. And also, as x approaches negative infinity, the graph is going towards positive infinity. So both of these are the same, whereas on the other ones they were different. Keep in mind that if this had a negative out front, it would flip this graph upside down, and so it might be M-shaped instead of W-shaped. The reflection that happens always happens across the x-axis.